Today we're going to graph linear inequalities in two variables. That means we're going to have an inequality that's like a less than or a greater than symbol, and we're going to have an x and a y. We've graphed inequalities with just x or just y, but not with both. Except really we have in Algebra 1, but I'm not expecting you to remember everything about it. So the way we do this time it's asking us which ordered pair is a solution of this inequality. So to figure that out, we can either graph the inequality, or we can just plug in numbers until we find something that works. Plugging in numbers is how I'm going to do this one. So I just start plugging in numbers until I find a true statement. Plugging in my x and y on all four of these, I notice that none of them are true until I get down to D. Negative 9 plus 20 is 11. That's the only one of those that's greater than 8. So I circle it and I'm done. Could have also done this problem by graphing the line and then finding out which point was in the shaded region. I chose not to do it that way because we haven't looked at a graph yet. That's what's coming up soon. At this point, you can pause the video and try these on your own, or you can do that later. So here's the process for graphing a linear inequality. First, we graph the boundary line. That's just the same as graphing any other line that we've graphed in this class. We use a dashed line for less than or greater than. We use a solid line for less than or equal to, or greater than or equal to. Then step 2 is not really how I do it. It says test a point on the line. I prefer to do it a different way. I try to think, if I were to get y by itself, if I see something like this or this, I know my y has to be smaller than whatever's after that, so I shade below. If I see this or this, I know my y has to be bigger than whatever my line is, so I shade above. That's only tricky when there's a minus sign in front of the y. I'll talk about that when we get to it. If you remember, we have to flip the inequality when we have a negative sign. Let's take a look. Part A says graph y is less than or equal to negative 3. So we draw a graph. We do our boundary line where y is negative 3. We make this boundary line a solid line because it's less than or equal to. I want the numbers less than negative 3 for y, so I go shade below. Part B, almost the same problem, just a slight change. This time our boundary line is going to be dashed because we don't have the or equals to. So I go to x equals 2, draw a dashed line. We can't really shade above or below this time, but I still want numbers less than 2, x value is less than 2. So that tells me which direction to shade. These are the numbers less than 2. Real fast to shade, just have to be careful to choose the right side. When I'm grading something like this, I'm looking to see, do you have your dashed line or solid line, and did you shade on the right side? Alright, so for part A and B, we're graphing two different lines. Your first step needs to be to draw the boundary lines. If you don't remember how to graph these lines, go back to the section where we learned how to graph lines. Review that. You need to know how to graph lines for this. In part B, I'll accept that it's a little harder to graph this one. I graphed using my intercepts. My intercept wasn't too hard to find. Plug in 0 for x and y equals 2. When I plug in 0 for y, I get negative 4/5. My recommendation is, if you don't realize that's between 0 and negative 1, put that in the calculator. When you get your negative 4/5, put that in the calculator, you get negative 0.8. Then you should have an easier time finding out that goes between 0 and negative 1. If you stop here on A and B, you've made a mistake. We haven't shaded yet. We have to do the right shading. Y is already by itself on part A, and I say I want bigger than negative 2x, so I need to shade above. Part B says less than or equal to, so your first instinct might be to shade below. But be careful of that minus sign. If we were to get y by itself, we would eventually have to divide by negative 2. Anytime you divide by a negative, remember what to do to this sign. Flip the inequality. So instead of less than or equal to, it's really going to be a greater than or equal to. So we shade above. At this point, you can try these on your own, or you can do them later. Go ahead and pause the video, read this problem, and try to come up with a plan of attack. Looks like we're recording a video with two different qualities. We've got standard quality and high definition, high quality. We can use some letters to define this stuff. Maybe X is my seconds of standard quality. And Y could be my seconds of high quality. Looking at the word problem, we see that the seconds of standard quality is 0.4 times the number of seconds, 0.4 megabytes times the number of seconds. Add that to the high quality, which is 1.2 megabytes per second. And that whole thing needs to be less than the total amount of space we have. And our total amount of space is 300 megabytes. And then it's telling us to graph this. Again, since this is a word problem, and we've got some weird numbers, we'll probably want to come up with a range of values for X and Y. The way I'm going to come up with that is by figuring out what would my X and Y intercept be. And I'll do that by plugging in 0 for Y. And I notice I get 750. If I plug in 0 for X, I notice I get 250. So that tells me where I can put my X and Y axis at. I'm going to go all the way out to 750 and 250. And if I were to get Y by itself in this equation, I would shade below, which makes sense because you don't want to have a graph, you can't have an unlimited amount of space. You're going to be confined to some amount of space on your video. Then it finally tells us to identify 3 possible solutions. There are an infinite number of right answers on this. Any point that lies within this triangle is an okay solution. So your answers may vary. Come up with 3 points that you think are in there. Test them by plugging them into our original inequality. As long as you come up with a true statement, you know you're doing fine. One more problem, we're going to graph an absolute value inequality. We graph the absolute value equation like we always do. Our boundary line is just going to be that absolute value graph. We see the vertex is at 3, 4. Notice I change a sign. It says -3, but you always change a sign for your x shift. And it looks like our slope, even though it's not really a slope, is -2. So we can draw that. We know to draw it with a dashed line because we have y is greater than instead of greater than or equal to. Put in our vertex, down 2 over 1, down 2 over 1 the other way. And at this point we draw the dashed boundary line. Y is already by itself and it says y is greater than, so we want all of the pieces bigger than this line. You can always check your answer by choosing a point in the shaded region and making sure that it gives us a true statement. Always a good idea, especially on a quiz or a test. At this point, you can try these on your own or do those later. Other than that, we are done with this lesson.